What is going on, guys? Welcome to this Python tutorial series for data science, and I'm very happy to introduce you to the first real episode where we get into data science, because up until now, everything that we've done with Python was either beginner stuff or some intermediate concepts like XML processing, database access, and these are fine, but now we get into some really interesting shit with data science. Now, in the last video, we set up Anaconda, we set up PyCharm, now we have the environment that we need. And in today's video, we're really getting into data science. We're starting with the real content. And the first part here is to learn about NumPy and NumPy arrays. Now, NumPy is a very essential library when it comes to data science in Python. The problem is though, or it's not a problem actually, but what you need to know about NumPy is that it in and of itself is not enough for data science. I mean, you could do data science even without all these libraries, but if you want to do some real easy data science in Python, NumPy is on a low level. It's the basis for the higher level libraries like Matplotlib, like Pandas, and later on also like TensorFlow and sklearn and so on. So all of these libraries or most of these libraries use NumPy as a basis, but NumPy in and of itself is just a library that allows us the efficient and effective processing of lists and arrays. And this is something that we need, of course, because everything that has to do with data science and machine learning has a lot to do with mathematics and algebra, and linear algebra especially. So we need matrices, we need vectors, and we need a way to really use these things and process these things in a very efficient way. And this is what we use NumPy for. NumPy is the basis for all of it. And since it's such an essential part of data science, we're going to learn about it right in the beginning. So let us get into the code. So now the first thing that we need to do when we work with NumPy is to import the module itself. So we're going to say import NumPy as NP. And this as NP here just means that I'm giving it an alias, so another name to use instead of NumPy, to make the code shorter and easier. You don't have to do this, but usually this is what you do when you work with NumPy. You give it an alias, NP. And this would be the same thing. Let's use a library that we know as saying import XML as, I don't know, X. I mean, X would be a quite stupid name, but I could give any library any alias. So I can also, I don't have to give it NP. I can also say my data science science library, but this would be kind of counterproductive. So we just say NumPy as NP. This is also what you usually do. And now we can use NP dot all the functions instead of using NumPy dot all the functions. And the first step here, or the first thing that we're going to do with NumPy, is to create a basic array. So a basic NumPy array. And a NumPy array is pretty similar to a Python list. So a Python list looks like this, if you remember 1, 2, 3, 4. And a NumPy array would actually just be np.array with a list in it. So we pass a list to the array function. So 1, 2, 3, 4, for example. And now this list gets converted by NumPy into an array, into a NumPy array, and then we can work with it. And it's not, it's pretty similar to a list, but it works very differently because our focus in NumPy is on mathematics, on algebra, on vectors and matrices. So when you add two lists in Python, you get a new list with all the elements. But when you add two arrays in NumPy, you actually do calculations. So let's create a second one of 5, 6, 7, 8. And what I can now do, of course, is I can use them as, or like simple NumPy, or like a basic Python list, sorry. So I can just say print A0 and print B1. And this would just access the individual elements. So now to run the script, for those of you who are not familiar with PyCharm, I right-click the main PY and then click on Run Main. And then I don't get a new window, but I get the output down here. So 1 and 6 are the results. The 0th index is 1, and the first index of B is 6. So this is what I get. And of course, what I can do with NumPy is I can also create multi-dimensional arrays. So I can say np.array, and now instead of passing just a list, I pass a list of lists. So the first list is the main list, and then in this list I have other lists. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this would be a 3 by 3 matrix, as you can see. So I could print C, and you would get, or you would see that this is here a 3 by 3 matrix. And to find out what shape an array has, if I don't see it or if I don't know it, I can just say print C dot shape. So this would be, as you can see, 3 by 3. So this would be a 3 by 3 matrix, and this would be a 4-dimensional vector. So we could already go ahead and do some calculations with this. So let's take two basic Python lists, x 1, 2, 3, 4, 4, and y 5, 6, 7, 8, and see what happens when we add x plus y. As you can see, what happens is I get a new list with all the elements. However, if this is a NumPy array, sorry, if this is a NumPy array, what happens is I do some algebraic calculations here. So I say array, and these are now two vectors. These are two 4-dimensional vectors, and what I'm doing by adding them is I'm doing a vector addition. I'm not just adding two arrays together in the sense that I add the elements together to form a new array. I do some calculations with them. So the result would be another 4-dimensional vector with the results of the additions. So 6, 8, 10, and 12, because of 1 plus 5, 2 plus 6, and so on. So this is basically what NumPy arrays are. So now let us take a look at the different ways to fill up NumPy arrays, because sometimes we want to create a NumPy array that has some default values or is already filled up with values, but we don't want to do it manually, because of course we could go ahead and say a equals np dot array, and then just say, okay, give me that shape. And here I have a bunch of zeros, and then I have a bunch of zeros, and I want to fill up an array full of zeros here, but I don't want to do it manually, because maybe I want to have a 5 by 6 by 7 by 8 matrix, and this would be kind of stupid to do that manually. And for that, we have a bunch of NumPy functions. For example, I can just say a equals np dot zeros, and I can specify a shape here, for example, 5 by 7 by 3, and then I can just print a. And of course, this will create a huge array of the given dimensions full of zeros, as you can see. So I have, let's take a look. I have 5 main lists here, so 5 lists full of 7 rows with 3 elements each. So this would be full of zeros, 5 by 7 by 3. Now, of course, I can do the same thing with ones. So this would fill up the whole array with ones if I need it for some reason. But I can also specify a value by saying np dot fill or full, I don't know, I think full. Np dot full, then specify the shape, and then as a second parameter, specify the number, for example, 9, because we're neural 9 here. And then you see it creates everything filled with 9s. Now I could also go ahead and say np.empty, and it would create me a NumPy array with values that are not initialized. Now, oftentimes these values are 0, but they don't have to be. So I can just say 8 times, sorry, 8 times 4 times 2. And when I say it's empty, we have different values. We have something like this, we have some zeros, but these values are basically not initialized. They're not 0, they're not some specific value, they're just empty. So we just created the structure, but there are no values in there. I mean, there are values in there, but these values are not initialized. So if you just need an empty array, use the empty function. Another very useful method is the random function. So np.random.random, we need to use it 2 times, np.random.random, and then we specify a size, for example, 5 by 5, and then it fills up the array with random numbers. from 0 to 1, as you can see. So these are all random values, and the array is completely random. This is especially useful when we want to train a model and we don't have, or we don't want to have a biased input. We just pass a vector or an array or a matrix full of random values so that we have a random starting point. This is something that we're going to use in the future. Yeah, basically that's it. I don't know, maybe there are some other functions. So for example, nan, but I don't think so. But these are basically the functions that we can use to fill up arrays, and they make a lot of things easier because we don't have to always fill them up manually. Now let's look at two more very important and interesting functions in NumPy. Sometimes when we create arrays, we want to have values of a range in it. So for example, I want to have 5, 10, 15, 20, 25, and so on, because maybe I have a mathematical function and I want to have the x values. So let's call this x right now. I want to have an array of all the x values, and I want to have them in a step size of 5. So actually, let's start at 0, 0, 5, 10, 15, 20, 25, and so on up until 30. And this is what I want. And maybe I want this up until, I don't know, 1,000 or something. So it would be quite ineffective to put all these values in manually. Because this would be my x values, and my y values shall then be, I don't know, x times 2 minus x squared or something like that. This might be a function, and we've seen that we can use mathematical functions on NumPy arrays because we actually do the calculations with the vectors or with the lists instead of just adding them or duplicating them. So this would be a valid function. We could just say x times 2 minus x squared. This would be a mathematical function. And I could go ahead and print that. One time is enough. I could just print that, and you would see the result of this function. But instead of just doing this manually, what we can do is we can use one of two functions. We can use a range or linspace. So a range would give me, it would be a function that I have to specify a start value for, an end value for, and a step size. So I say, give me all the values from 0 up until 1,000 with a step size of 5. This would be what I want. So it would give me 0, 5, 10, 15, 20, 25, and so on up until 1,000. And then I could just go ahead and calculate the values. So here I would have all the results for these values of my function. Of course, I can also use a NumPy function for that. For example, I can just say, okay, give me the sign of it. So np.sign, the mathematical function, np sign x, and then I would get the value of that. I can do everything with these values. Now, another way to do that, if I don't want to do it like that, I can say linspace and say, again, minimum and maximum. But now instead of saying I want to have a step size, I say how many values do I want to create evenly distributed. So instead of saying give me every value that is 5 larger, I say give me 100 values in between. So I can just say give me 100 values. Let's print x to see what happens. It gives me these values because these are the evenly distributed values from 0 to 1,000 if I want to have 100 of them. I can also say give me 101 maybe, and then it would change the values, because then I would have 101 values evenly distributed between the minimum and the maximum. So this would be another way to do that. And this is usually how we create the x values or all kinds of different input values, because we just want to have a bunch of input values to calculate the output for. So last but not least, let's take a look at some of the attributes an array can have. So if I create a equals np dot array, and then I say I have a list of lists, and then I have 1, 2, 3 in here, 4, 5, 6 in here. And then I have another list here, and in this list I have 10, 20, 30, and 40, 50, 60. What I can now do is I can get some information about this array. So for example, I can just, as we already did in the beginning, I can just get the shape of it. So a.shape is one of the attributes that I might be interested in. And in this case, I have a 2 by 2 by 3 array. So I have two lists in here, two main lists. Then I have two lists in this list or in these lists. And then I have three values in each list. So this would be 2 by 2 by 3. But maybe I want to know how many elements are in my array. So a.size would be a good indicator of that. So 12 because I have 6 here and 6 here. One thing that I would like to mention is that we don't need to always have the same structure. For example, I could also add a list of two values in here. So I would then have two lists here and three lists here, and one of the lists even has only two values in it. Of course, what happens then is I cannot really print a shape anymore because I don't have a shape. It would say, okay, you have two main lists, but basically that's it, because in there you have a different amount of lists and a different amount of elements. So I cannot give you a shape. What I can do, however, is I can get the dimension of an array. So I can get ndim, sorry, not dim, and it would give me how deep an array goes. In this case, it would give 1 because I have only one dimension that is the same. It would give me, you have one dimension here, but then already you have two elements here, three elements here. We cannot talk about dimensions. But if I remove this, it would say that I have three dimensions, of course, because I have the same values. I have 2, then again 2, and then 3 each. So when we're dealing with the same shapes, we have dimensions. In this case, 3 dimensions, of course. And another attribute that would be quite interesting is the data type attribute. So in this case, I have a bunch of integers in here, but I can say a daytype or dtype, sorry, and will give me int 32, so an integer with 32 bits. Of course, I can also specify a data type. So at the end of the definition of list, I can specify dtype equals float, for example. And then I would get the data type float 64. And if I print a as a whole array here, it would give me the same numbers, but in a float format. So I have 1 point, 2 point, and so on. And this is basically what we can do with the attributes. We have the dimensions, we have the size. The size gives us the amount of elements. The dimension gives us information about how deep the array goes with the same shape. The shape gives us the shape, obviously, and the data type gives us the data type of the individual elements. So this was the first part on NumPy. In the next video, we're getting deeper into the material, and I hope you liked today's video. I hope you learned something. If so, hit the like button, and feel free to ask any questions and give feedback in the comment section down below. Of course, subscribe to this channel if you want to see more. Keep watching the videos. We're getting deeper and deeper into data science as we progress, as we go on. And again, thank you very much for watching. See you in the next video, and bye.